Hello, hello. Welcome, everybody. We will start today's very cool presentation in a couple of minutes. Okay, so we are getting to the 2-minute mark. Let's get things rolling, shall we? Good afternoon, everyone, and thank you for joining us today for our weekly Improving Talks. This month's theme has been incremental tech modernization, and today we will continue this series with our very own guest of honor, my Houston friend, Terence Persaud. Terence has been a senior consultant too at Improving since September 2020. He's a web and mobile developer with 10 plus years of experience in .NET and Node.js. He has lived in the USA, US Virgin Islands, UK, and Spain, giving him a global perspective that has shaped him into the very interesting person he is today. Some of his hobbies are attending live events like music, comedy, and sports, traveling, movies and TV, reading, and board games. I am thrilled to welcome him today with his talk, Building Incremental Assurances, Alleviating Uncertainty Through Incremental Change. Today, he will be exploring the transformative power of incorporating manual, unit, and integration testing with mock data, revealing tangible benefits such as verifying source code functionality, streamlining code cleanup, and minimizing documentation overhead, amongst other things. Before we start, I encourage you to use our Q&A feature so you can ask questions, which I will be sending his way at the end of this presentation. And without further ado, I leave you with Terence Persaud. The microphone is yours, my friend.
Thank you very much, Armando. That was a very, very nice introduction. All right. And we are. Let's go ahead and share. All right. So as Armando said, my name is Terence Persaud, and welcome to Building Incremental Assurances, Alleviating Uncertainty Through Incremental Change. Now, before we begin, I'd like to start by going over the motivation behind the talk before diving into today's topic. This talk is to alleviate some of the fear around iterative and incremental assurances, both from a business management aspect and from a technologist perspective. I've seen this aspect applied many times to all types of software at various stages of an application's maturity. I've seen it help speed up a proof of concept, which demonstrated a project's vulnerability. I've seen it help an MVP demonstrate that it was properly calculating complex physics equations and engineering equations. I've seen it help maintain a mature and robust live application while giving developers time to redesign the user interface and the user experience without having to throw away years of legacy code. I've also seen it help developers understand and revive long-dreaded legacy applications that needed to be maintained after a colleague retired. Now, there is a very low bar of entry for this. I've seen technologists at every level, and from entry level to architects, and I've done it at most of my aspects of my career when it was necessary and when it was allowed. So with that in mind, let's go ahead and begin and start going over the overview. All right, so today we are going to be covering defining what incremental assurances are, understanding how this affects our software lifecycle, And then we're going to get to the fun parts. We're going to walk through adding incremental assurances into a new product to alleviate uncertainty on a mission critical initiative. And then we're going to have a walkthrough of adding incremental assurances into an existing product. I might have accidentally, oh no, I did keep those, I did flip the order. All right. Now, the first thing is, what are we talking about? We need to define incremental assurances. All right. Incremental assurances is the process of taking a systematic approach, a systematic effort to incrementally guarantee that an application meets a provable requirement of design, performance, readability, and maintainability for the end users, the developers, and the support team. The goal of incremental assurances is to grow into a modern application that can handle this criteria. Now, it's not so much that it's a textbook term, but more of a generic approach of how to appreciate and to achieve a minimum level of software quality, dependable deployments, and overall end user satisfaction. Now, your end user can be anything from yourself or some R&D department in a company you work for, or it could be a big tech company and publicly worldwide. Any of those scales, you are the end user. Now, with that in mind, as I mentioned, multiple different types of audiences also means that there's not really a one size fit all kind of method. You cannot just take a panacea. Not everything will be cured. Now, your team can make this judgment, okay, of what's enough. Maybe you don't need a CI/CD pipeline because it's just a simple Excel macro to help you write a report. You might not need that. Maybe you need multiple deployment pipelines and Docker calculators if you're working on a UI/UX redesign for a company's flagship product. Okay, and if you're responsible for that and that flagship product is responsible for the revenue, you need to make sure that it's working all the time or as much as possible. You don't want to do anything that could jeopardize them. Now, the goal of incremental assurance is eventually you can grow to this. You might not necessarily be there now, and that's okay. Everything starts at just a simple place. Okay? Now, with that in mind, you might be wondering, what exactly is application modernization? How it relates. In fact, I thought about it when I first was writing this, and I went to Wikipedia because that has everything. And so I came with they had this definition here. I don't know if I can read that out loud. It's very long, I'll be honest. But it kind of boils down to, well, I'll let you read it real quick. All right. Now that you've read it, it kind of boils down to legacy modernization refers to the conversion, rewriting, and porting a history of legacy systems, modern programming languages, architectures, examples, microservices, software libraries, protocols, or hardware platforms. The legacy transformation aims to retain and extend the value of the legacy investment throughout the migration to new platforms to receive benefits of the new technologies. That's a very large and cumbersome definition. It's very verbose. It's very generalized. It doesn't necessarily explain everything we need for our needs, though. After all, it is Wikipedia, so they're appealing to a wide swath of people. They're not appealing to just one small set of me, which would have been awesome, but it's not the case. Now, I'm going to try and break this down into what this means and what this doesn't mean in more layman terms so that we understand the intent behind the definition. All right. All right. So what application modernization means? It's more about ensuring that an application and the source code will survive in the future. Throughout our lifetimes, we've seen hardware and technologies, languages, methodologies, all these things might become deprecated. Some things have become deprecated. All right. Also, the users evolve to use different tools. A lot of us, maybe we might be a little older, we might be a little younger, depending on your age, of course. We saw this when mobile phones and smartphones became more popular and prevalent in society. So about 2010, 2012, anywhere from 28 up. A lot of the websites that were built for the internet were only built for your actual desktop machine. They weren't really built for even laptops. Once the smartphone started getting into people's hands, that's when people started going, okay, well, we need this to work on our phone, our computer, a laptop as well. So that's kind of like where it transitioned. Now, what if we were to start thinking about how we had this transition from computer first to mobile first, like a home remodel? Most of the time, houses are renewed, renovated, amenities are there, additions are made. People don't usually tear down their houses and rebuild from the foundation upwards unless there's major structural issues that cannot be fixed or a catastrophic event happens, like a hurricane. But in order to evaluate this, you have to look at it on a case-by-case basis, okay? Now, I'll give you an example. Suppose you have a great desk, you have a great home, you have an awesome den. You just want to change one plug from just an electrical outlet to also have a USB plug so you can charge your phone while you're working at your desk and not having to use your power strip because that's also connected to something else. Seems simple just to go to the store or buy the new plug. You can use a delivery service. Turn off the electricity, turn it back, replace the plug, turn it back on. You might not even need that. There might even be one that you just plug into the wall itself. I don't know. I don't know what you're doing today. You could do any of these options. But that's a lot simpler than tearing down your house and rebuilding it just to replace a plug. That's all it is. Now, the converse of that, sometimes a hurricane or a tornado will hit your house. You got to replace it. You just don't have a choice. That's kind of what I mean by evaluating the situation. In fact, the same evaluation skills that you use there, you have to use when it comes to software. It's very expensive to have to rebuild software from the ground up. No one really wants to do it. You have to factor in the extra development hours, the extra QA, extra planning. It could take, and also the extra time. It could take up to years, like 2-3 years. It isn't cheap. So when possible, we would like to salvage older projects and transition them from legacy software and reclaim whatever we can. Now, also, with that in mind, we have to explore what it does not mean. Application modernization is not about automatically converting and rewriting or porting over legacy systems to new programming languages. It's not about just automatically putting things to different architectures or using newer libraries without a rhyme or reason. There needs to be a deliberate choice in what you're doing before you modernize it. Throughout our lifetimes, we've seen, just like I said before, a lot of technologies will come. A lot more come and are not adopted. For example, Microsoft had a Zune. A Zune was an MP3 player that competed with iPod. Well, it didn't really compete with iPod because we don't use it. The iPod was here for 10, 15 years. The Zune was here for 6 months. Back in the day, there was Betamax, which had a superior quality, but lost to VHS because VHS was more accessible to the public. There are dozens of examples that we can give over the years. But that doesn't mean that you have to adopt everything all the time. It's not about trying to blindly replace a monolith SQL server with microservices and a MongoDB backend just for fun. The monolith could just be working at the ways it is. You need to work the way it is and just upgrade whatever's supporting it. That's a very valid option as well. You need to weigh the pros and cons, have a few discussions, and then make a plan of attack. Don't just change things because they seem cool. That's called resume-driven development, and that's actually very bad. If you develop for resumes, you will have to plan to use your resume in the future. Do not choose things to develop just because they're resume builders. Choose them because they're the right tool. Now, another aspect of application modernization is that you want to actually kind of design things to where you can pick and replace what you want to use. You want to pick out the bad, put it in the new. You can replace things. Think of it kind of like a bunch of Legos. Okay? My nephew likes to play with Legos. Now, he has sets of Legos. Sometimes he's building the set. Other times he just wants to replace a green Lego with a blue Lego. Both are valid, both are fine. Might not necessarily need the instructions, but he has the options to do it. That's kind of what we want to get from map modernization. You can keep things the same, or the way they are. You can pull things out as needed, but the system still works together. That's the goal. Okay. It's like when you take it back to the home analogy. You can renovate an old house and you still have modern comforts. Whenever people go to houses here in Houston or in New Orleans, anywhere in the South, a lot of these houses are very old. They're hundreds of years old, but they still have air conditioning. They still have heating. They still have electricity. They might even have, they might have Wi-Fi. Some of them are even smart houses, but they still have the bones of the house. So that's kind of where we're going with it. And it's the only way to really provide and make sure that your stuff is able to be used in the future. Now, with that in mind, let's go ahead and start looking at how we can start adjusting this into our software lifecycle. Okay. Simple question. How does this affect the software lifecycle? It will affect all of it. There's no way around it. Things are not done in a vacuum, and they will gradually just get into everything. Now, sometimes that's good, sometimes that's bad. Change doesn't mean good or bad. It just means change. It means something is different. That's all. So let's just explore how this will affect our lifecycle. Now, regardless of your software development methodology, you could be using waterfall, rapid application development, agile. You could be using different aspects of agile. You could be using Scrum, Kanban. Doesn't matter. You're probably doing some aspect of this right here. There's just these 7 steps. How often you do them, indifferent. The fact that they're getting done, indifferent. It's just that that's the way it's going to happen. So eventually, all of your incremental assurances will affect each stage. But it's not a shift in the process. Your process can remain the same way, however you're currently running your team. It's just a shift in mentality and implementation. Remember earlier, I said the goal of this is to incrementally progress towards an application having all of the modern comforts. Okay? It needs to have a provable, efficient design that can be read, understood, and maintained by developers. It needs to have a performant feel with less bugs for the end user. That's the goal of incremental assurances and app modernization. Now, the question is where to start, okay? And it's kind of a chicken or egg thing. It's a causality because it depends on the buy-in from your team. You might start in development. Just throw in a unit test. You might start at the planning and phasing. You might actually just go, you know what? I'm going to actively push towards this. You can do those things. I'm not going to make that decision for you. Okay. But eventually it will catch up and it will get in all your phases. And that's okay. That's actually the goal. Okay. Now, can't tell you where in the phases of the cycles it's going to start. But what I can tell you is that it'll probably be 3 phases before there's full buy-in by the whole team. Okay. Now, someone somewhere will see a change. I don't know who, I don't know where, but it will happen. Okay. They will see that buy-in. They'll start to see the progress. Now, remember, I told you at the beginning of this, I'm going to walk you through 2 scenarios. Okay. But they will cover in some order these 3 phases. We are going to plan to add or increase test coverage, add the testing requirements, figure out a way how to integrate them, build the task, evaluate the test, deploy the new code, and maintain the business requirements through the test. Now, we're also going to plan to increase the coding standards and practices, add coding enforcement, figure out a way how to integrate that into previously written code, build the task and test, evaluate that the code enforcement taking place, deploy the new enforcements, and maintain that idea. We're also going to plan to evolve the deployment process. We're going to add validation checks and balances requirements. We're going to figure out a way to necessarily rewrite all of these, to evaluate all these tests before we release it. We're going to build a pipeline, possibly. Evaluate that everything works together and deploy the process and then maintain it. I don't know when, I don't know how, but somewhere during these phases, this will happen. All 3 of these things. Now, we could analyze every single aspect of how to add this in there, but the 3 main ones that are really important to developers are going to be development, testing, and deployment. So, no matter what, we as developers, we control and influence source code more than anyone else. The goal is to add tangible, provable progress towards this application becoming more performant, readable, and maintenance friendly. In this phase, it could be adding a unit test to a new function, adding a unit test to an existing function, rewriting how a layer of a project works, adding a new data set. It could be adding a new process. It could be adding anything. It doesn't matter what the particulars of the situation are. The only thing that matters is the goal, that some progress is made in this phase. Okay. And with that in mind, there are 3 types of development changes. Yes, 3. There are only 3. No matter what, there are only 3 development changes. Okay. This will help us establish our code. There is iterative. There is incremental. and there is a combination of the two. It's called iterative incremental change. Yes, that's exactly what it's called. I didn't make up the term. They just combined them together. All right, now, it's really hard to quantify what iterative or incremental is in words. Not really hard. It's just, it's kind of like looking at the Wikipedia definition. It's a little longer. So I'll just walk you through with pictures. Okay. Remember, these are often conflated, but they're not synonymous. Okay. A lot of people think they're the same thing. Usually when you talk to developers and technologists, we aim to be very precise and accurate when we describe things. However, this specific terminology always gets conflated, but they're not the same. They're not synonymous. Nearly 20 years ago, a guy named Jeff Patton wrote a blog that explains everything we need to know about these in 4 sentences and 2 pictures. Incremental development is where you're kind of adding everything in at one time. You're making sure every single part that you add in is perfect. And you're going through piece by piece by piece until you get the whole picture. He used the Mona Lisa, for example. So you're focusing on one area, making sure everything's good with her face, moving down to make sure her right side's good, then her left side. In fact, and he also said incremental development, I mean incrementally add software at a time. Each increment adds more software, sort of like adding bricks to a wall. After a lot of increments, you get a big wall. That's all it is. Adding bricks to a wall. Second one. This is incremental. Artists work iteratively. They often create sketches designed to create a painting, create the underpainting showing colors and form, then eventually finish the painting. Begin finishing the painting. They stop whenever it's good enough or they run out of time or interest. And he's right. The Mona Lisa was painted in layers. So if you look at it, each layer they went through and added different colors, made sure each thing came up until a couple layers later, they had the Mona Lisa. Most painting is actually done this way. So there you go. That's all it is. Those are the only differences between the two. Now, how we will probably do most of our things. Iterative incremental change. Sometimes we'll put down a layer here. We'll go, oh, no, let's focus on some details somewhere else. Let's put some details, put down a layer and then put down the details at the second part, go down to a third. Eventually, somehow you'll have a whole painting. But it's not necessarily one or the other. It's a combination of the two whenever they're needed. You can choose when to stop at any point. You can start, stop. It's really up to you. You're kind of just free-forming it. Well, once you have your desired code, you would eventually go to testing. So I'm not going to walk you through what testing is, but the goal is to evaluate our system through approvable testing that we have built through our development. We're going to assess whether the application has started making progress towards becoming more design, performance, readability. If it has those things, if it's maintenance friendly, if we can start understanding it. We've created the proof that what we have made works in our development phase. We're evaluating now whether not only this new proof, but our old proof still holds true. So we're evaluating the situation, making sure everything's there. If it doesn't pass all the tests, we can go back in development and make that right at that point. Okay. You might not have all the tools that you need. You might not have a full CI/CD pipeline. That's okay. You can run the test manually if you need. Just start somewhere and eventually get to where you go. You might want to use functional testing. They're, that black box testing to make sure that things work as far as your functions and your methods inside the code, whether they work together or not, or the whole system works together. You might also need to evaluate your hardware as well. You might need to check and make sure that it's secure, that it's performant, so the end users are happy. Either way, you're doing that in this phase. You're making sure once those tests are run that they're good. You would have added these tests or developed them in the previous phase. But here we're just evaluating and making sure that they are all in there and that they all are good. So we've added an increment to that. Slowly but surely, we're getting to the goal. And the third one would be deployment. Now, there are two ways to really think about deployment. There's big bang and phased. Now, that really depends on how you as a developer or a technologist, whatever you want to do on the dev side, want to display this to that user, okay? You might want to have a big bang. A big bang is where you kind of take a sledgehammer, you got the dash for the cache, you're showing everything at once. You can do that. Maybe there's just a whole redesign you're waiting to deploy. You've got it all ready. It's ready to go. Cool. This is your actual chance to deploy. Other times you just want gradual updates. That's phased. You're just not shocking the system. You're just letting it trickle in. Just slowly get in there. Eventually, the user might not even notice the differences. They might see a screenshot from 5 months ago and now. They would have never noticed that those are two totally different UIs. That's the idea of phased. You don't have to do either one. You don't have to do a one and stick to one. You can do a big bang and then 3 phased and then another big bang. It's up to you. You get to choose this. I can't tell you what to do. Now, regardless of whatever methods you choose in your phases or how often your phases go, okay? No matter what, if you give a lot of updates at one time or you phase and changes, that's not important to the incremental assurance. The ability to consistently deliver a stable product is the goal. To consistently be able to show that you have maintainable things, that you have a maintainable process. That's the incremental assurance that you're looking for, that it will do it the first time, every time. That it will do these tests, okay? That you are reducing overhead, okay? So you might start off with understanding the manual process and reducing it down. You might also, you might start there. Then you might start automating where it's necessary. Automating just a little bit of publishing. But then you might also automate all your tests, all your security. You might have a very, very secure automated situation. You might evolve to that. And that's another goal too. But eventually you have built in whatever level of assurances that you need for the deployment to ensure that it's there when the customer or the end user needs it, whatever stakeholder you have, incremental. You haven't had to do it all in one go. Okay. Now that we understand this, let's go ahead and start taking a look at our scenarios. Our first one, adding incremental assurances in a new initiative. Okay, I'll walk you through a scenario first. Remember, Benjamin Franklin said an ounce of prevention is worth a pound of cure. What he meant by that is, do it right the first time. Make sure you're prepared. It's better than having to do a lot of things later. And I truly believe that's the case, especially in this instance. We're just setting up everything we need to know. You're a company, you work at a bicycle courier service. It's cool. You get to go, there's a guy, he goes riding around downtown, hands out letters, goes between different courts. It's a cool job. You support that job just with your tech. They get to go ahead and figure out when things are going, where they're going, what time they got to be there. make sure they're checked in, that the logs have been signed. But they're pivoting focus from only that. The owner has gotten a new contract and has gotten a deal on getting a whole bunch of vans. Found a contract to add to start working with the airports in town to go ahead and deliver lost luggage. Apparently, it's very lucrative, so he hired some drivers. But the contract starts. Now, one of the contract has a stipulation that all software must be up and running on the first day of operation. The company will probably go under if you don't. This guy totally doubled down, tripled down on this bet. Thinks it's going to work. You just have to get with the program. Your go live date is 1 year exactly to the day that the contract is signed. He has let you know that day. Now, you must match the UI UX standards from the internal dispatching department, because they need to understand how to handle these packages, how to be able to dispatch them to the drivers, tell them where to go. There's a third-party scheduler that hands the schedules of things to the dispatchers as well. Dispatchers will figure out where these people need to go, and that's how they're going to go. That's how it's going to work. They also need to know where to drop off this luggage. So there are three main roles. There's technically a fourth role if you count yourself as an admin or whoever the admin is. That is scheduling, that is addressing who the users are. There are things. You could say 3 or 4. It's, however you interpret the situation. Now, originally they had wanted to do 4 mobile apps for, everybody. Different type of effort, but you convince them that you can use authentication and authorization instead of multiple mobile applications and just create one mobile responsive PWA, progressive web application for those that don't know. They're going to be able to have it on their phones if needed. They're going to be able to connect to the information. They might not necessarily even know that it's not that it is not a full mobile app, but they have access to it, and that's the important thing. So the first thing you do is you develop a plan of attack. You decided to choose a well-supported modern language and framework that everybody knows well on your team. Everybody on your team knows well. For me, in my team, that would be a mean stack: Mongo, Express, Angular, Node.js. You could use Core or .NET Core. You could use Java. You could use PHP. Those all have modern tool sets. That's fine. But what you don't want to do, but whatever choice you do, you want to make sure that it has not just coding standards for you, it also has testing. That's something else you'd like to do. Suppose you chose a Visual Basic and you don't like it, flip it out early. The earlier, the better. You want to bail fast and replace fast because you need to be in a rapid development in this case. In our case, we also need to figure out where this application is going to be hosted. We could take it on with servers, or we could host it in the cloud. Choosing the cloud seems easier. It eliminates our risk. Personally, I would choose Docker and for my container, and I would choose Azure for my hosting service. The idea being is that Azure has, I think, 5 minutes of downtime per year as a guaranteed 5 minutes or less downtime per year. I can live with that. I can't live with me not being able to fix a server or waiting for a part. That's not going to be very viable for this situation. My Docker container, I can control the environment and make sure that it's the same environment every time. You don't have to use these specific tools either. You could use GitLab, Amazon Web Services, Google Firebase, something. Just do some research, choose something. You might choose Heroku. I don't know. It's your day, it's your world. Choose what you like. Now, you might not even like Docker containers either. You can choose Vagrant, Kubernetes, Podman. Doesn't matter. As long as you understand it, quick study. Pick and choose what you want. That's kind of the idea. You are in control of your domain. You are in control of your own realm. You're in control of your own destiny. Perfectly great. But like I said before about the languages, if you're starting to find things difficult or that they might not necessarily have what you need, bail quickly. Do not try to make something work for months at a time. You might not need it. You might not know it. It might be difficult for everybody. If it's not a learning curve issue, you might need to get rid of it quickly, especially in this case where you only have a year to provide a very detailed product for all the customers, and that knowing that it is actually for more than just you. Okay. You're going to also go through this. You're going to build a hello world. In this case, the reason why you're building a hello world is not just to show that you can build a hello world. It's actually to go ahead and show that you have all the pieces you need, all the testing, all the deployments set up. Hello world does not just refer to the code. Hello world also refers to your developer tools, your checks, your balances, everything. Once you have all that set up, you then at that point can control everything. If you have everything set up, you don't have to do it again. Okay. It might feel like killing an ant with a bazooka, but the ant will grow bigger. It will grow as big as an elephant. It's not a matter of if, it's a matter of when. You know this going in there. Just set it up now. And so let's go ahead and start taking a look at the Hello World first phase. We're just going to create a new repository. Use Git. I would use Git. Like I said before, Angular. Just create a Hello World app. I would add my ESLint, Prettier, keep Jasmine for the unit testing. So it comes out the box. I don't have to do anything. You get that in there. Then I would probably use Playwright for my end-to-end or unit or what eventually will be my integration testing. Make sure that that works. Create the Hello World on my box locally. That would take me about 10 minutes. It could take up to an hour and a half. It just depends on the experience of the developer. Not a bad trade-off. Now, once you have this Hello World locally, you want to show those other departments what you got going. So you're going to create that Hello World. You're going to go ahead and set up your Docker container so that it holds the project. Make sure that works. Once you have that, you're going to manually verify that it can pull up, that it does work, and that you do see Hello World on your local host. At that point, you will then push that to your Azure site. Make sure that works. Just that it works, not necessarily connecting your CI/CD or anything, just that it's up there. Make sure they can see something, and then message them without leaving your desk. My goal is to sometimes just tell people something's up there, and then once they see it, work on whatever's needed inside. They want to see the thing first, just the visual thing. They will understand if you're working on the back end or you're working on the things they cannot see. It's kind of like building a frame of a car and then going back and then making sure the engine can go in there. Sounds counterproductive, but it actually makes some sense in a weird way. All right, now our goal is to make sure that our pipelines are set up in our third phase. So we're going to start adding in continuous integration. Now, in this case, I've been using this term and I haven't defined it for you yet. Continuous integration is just the practice of making sure that the developer integrates their code changes in a shared repository frequently, and that we're evaluating frequently. We're rejecting things that don't have proper coding procedures that we don't like. So we're like our linters are making sure that we use a dangling comma, certain things. Whatever you choose, that's what it's going to evaluate. We're also making sure that it passes all the tests and making sure once it passes all those, then we're accepting the code.
Terrence, just time check, 11:45.
Okay. All right. So I'm going to try and go ahead and rush through this one. Yeah. So then you're going to go ahead, make sure it works, test it manually. And then you're going to add your continuous delivery, which makes sure that your actual automation process is released, that it actually builds and deploys the project. Once you have that delivered over to that, then you're going to replace your deployment and do that and make sure that that goes. So your fourth step, once that's out there, everybody's able to see it, everybody's able to go. They are now able to go to a backend server. We're going to go ahead, create that server, add the hello world for the backend, make sure that everything integrates together, update our end-to-end testing. We're going to add some end-to-end testing, make sure everything's there, make sure that all of that connects together using these hooks, and then update our CI/CD pipeline. Now, what does that actually mean? Once we have manually verified everything works, we were able to, in about 8 to 10 hours, depending on how quick your guy is, anywhere from actually maybe even less, maybe 6 hours, quickly implement a tool set all the way out that will last through the whole project. This now will last the whole year. You don't have to go set it up again unless you really want to make changes. You've showed the hello world to all your departments while they're doing other things. They can sit there, they know that at least that's there. You gave yourself some assurances. So later on, you might have some things that you have to change. You might have some things you don't remember to check. I myself, every other developer in the world, sometimes writes things a little too fast and misses a case or two. It happens. But we now have a way to check and make sure that if this case fails, it'll let us know quick as soon as possible. We can automatically deploy once it passes these validation checks. So you don't have people asking you consistently, when's the new update? When's the new update? It's consistently just going there. Just go look at the site. You do that on your own time. I don't need to tell you to go look at it. It's there. And I now have all this time I would have to use for answering those questions back for myself. Back to waiting for requirements from the other stakeholders. Back to being able to develop what I need. Now, I'm going to quickly rush to the second scenario. Sorry about that, Armando. I didn't realize how much time was there. My clock was a little.
We're all okay. Don't worry.
So we are going to start looking at adding incremental assurances into the existing products. Now, little by little, one travels far. J.R.R. Tolkien said that. And that's what we're doing here. So we've been hired by a company to join a team of senior devs with a lot of internal and external projects. All the developers have a desire to eventually modernize their apps and solutions. The manager doesn't quite have it yet, but they're getting there. All the source code is in Git, written in older versions of the same framework, and some of them are in different languages. Let's just say that it was in .NET and some were written in C#, VB, and C++. Seems simpler. It's a thing everyone knows. That's been in development for a while. These are languages there. They're all still in the same framework. Now, your first task is that you are given an application that is a spreadsheet parser that the accounting department uses. So the accounting department has 2 different sets of invoices that they have to process every week. One on Mondays, one on Wednesdays. So you have to make sure on Mondays that it's ready, and Wednesdays that it's ready for a different format. And once a quarter, you have to do a third check to make sure that you can evaluate all the quarterly invoices. And it's what they use to interact with the ERP system. Now, the person that designed this is retiring. They're going to Bora Bora. They won't really have a phone too much that they want to ever talk to the company. In fact, they said so, and they said that they were going to charge the company $20,000 an hour. So the company never wants to talk to them again. It happens. Sometimes people want to retire and not talk to people. I don't know what to tell you. Now, you're allowed to rewrite code all you want, but you're not necessarily allowed to change what's expected, the deployment process. Your boss wants to keep it that way because he knows that's how it works. And the last thing is your source code is averaging about 10 months, bugs a month. Now, we don't know if that's because of fat fingering, because you have to change the code twice a week, or if that's due to the frequency of the deployments, or if there's actual logics inside of it. We don't know. All we know is we've been given this thing. So our plan of attack is simple. We're going to create our own documentation through tests. Okay. We're going to add unit tests on what the functionality currently does. Then we're going to slowly start integrating what we understand. We're not going to make any changes. We're just going to integrate in and understand what it is. Then we're going to start cleaning up and preventing bad commits. Whenever you fly in an airplane, they tell you to put on a mask, an oxygen mask first before you help others. That's kind of what this is doing. So our first phase, we're going to put on the oxygen mask. We're going to update our local source control hooks, not anything to do with the repos, just locally. We're going to go ahead and add that in there. We're going to make sure that it runs a resharper and that it runs unit test. That's all. Or resharper, JUnit, whatever. We're going to create a unit testing solution, and then we're going to start creating tests on just what we have, just what we know. If it says the 14th address of an array throws an error when it equals 0, that's what we're going to write in the test. That's all we're going to test. Then we're going to go to phase 2. At this point, we've started incrementally proving the functionality of each method. We now have some assurances that that's how it works. It's not great. It's not good, but it's something. And that's what we could start with. So then we're going to start adding integration tests and start cleaning up our code smells, whether things are not right in any direction. We're going to start cleaning those up. And once we do that, we start gaining a provable way to start going to our goal of modernizing this app. Okay. We can now start going to business practices and starting to ask them what they need. We have the documentation for it. We now know how the code works. At that point, you've established buy-in from the other departments. Your team noticed a significant drop in bug tickets because you're able to understand the system. You're able to free up some time in your schedule. Your boss notices this. He starts asking if you can start putting in some of these things you were talking about into the repository. So you're able to start rejecting code at that point. He's allowing you to do that. You're slowly getting there. You're cleaning up your source code, and eventually you will be able to get to these automatic deployments in the next phase. But it took about 3 different iterations to get there. All right. Are there any questions?
That was great, my friend. And yeah, we already have a couple of questions here for you. First one, can you please talk about the cost benefit of incremental insurance, in your own opinion?
Right. In my opinion, and anecdotally, I've noticed that it's easier to prove something doesn't work and to reject things than it would be to let them go in the system and then have to spend time to clean them up afterwards. So just from the time analysis alone of having a developer have to do that, you save that benefit. Do you want me to go into more detail, or do you have other questions?
Yeah, we have another one here for you that says, what strategy can be set in place for refactoring and improving legacy code without disrupting ongoing development?
Oh, yeah. Well, kind of just work it in as like a cleanup ticket, maybe. That's one way that I've done in the past, is just, okay, cool, I've got this. I got about an hour. I noticed the problems. I can start adding these things in incrementally. You are slowly just adding these incremental assurances. It's not going to happen overnight. They will You can do these things in your part-time and eventually get there. The goal is not necessarily that everything happens at once.
Yeah, that makes sense. Thank you, Terrence. And the last one we have here is, how can we ensure that performance improvements translate into tangible benefits for end users?
Well, this is going to sound weird, but you'll stop hearing from them. They won't be writing as many bug tickets. They won't be coming up to you for this. One thing I heard a long time ago, the IT department, they're never around when things are working, but they're always around when things aren't. The idea is you don't want to be seen. People don't want us necessarily to be there in there every day unless we're developing new initiatives. They want things to just work. So let's go ahead and make sure things work. And once they do, and the customers are satisfied, or any stakeholder, we will hear from them less. You really only get bug tickets, and that's when you hear from customers. If you are in IT, you might hear from good things from management. They might talk to other people. But as a developer, when you start getting emails about these things, that's when there's issues, because people don't send us thank yous. It's unfortunate, but it's true. Are there any more questions?
That's all the questions we have, Terrence. You can
All right.
go ahead with your closing remarks.
All right. Well, thank you very much for everyone that's joined. I will also be talking next week with some people here. I am going to be talking with Marina, myself, Michael, and Reed. We will be going and having a roundtable to discuss some of our previous experiences and app modernization, and it will be a fun discussion. I hope to see you there.
Thank you, my friend. So, as we saw today, iteratively integrating certain practices into a project can gradually build incremental assurances, which at the end of the day will make your life much, much easier. That's all for today. I want to thank you all for joining us, and especially my friend Terrence for sharing this great presentation with us. And as he mentioned, coming up next week, we left the best for last. We will be closing up this incremental tech modernization improving talk series like champs. The business case for application modernization, a roundtable discussion with our panel of experts, Marina Boriskevich, Reed Spencer, Michael Perry, and the man of the hour himself, Terrence Pursuit. Be sure to register. Until next time, everyone, have a great rest of your day. And again, thank you very much, Terrence.
Thank you, everyone. Thank you, Armando, for having me.